Alright, did anybody not look at the problem? I really don't care. I'm just gonna go over the problem. If no one went over, nobody looked at it. If there's somebody who hasn't looked at it, we can look at the problem. Okay. Okay. So yeah, let's just pull up the problem anyway. Okay, so write a recursive method sums that takes in a string s and a long n that determines if plus symbols can be inserted in the string of digits s so that the resulting arithmetic expression sums to n. So then they give us some examples here. 1, 2, 3, 4, and 37. And then to get to 37, we could put a plus here and a plus here. And then we would get 1 plus 2 plus 34 is equal to 37. And there's some scenarios where no matter where you put pluses, you're not going to get the output. Okay, so basically, if you think about this from the start, the first thing you're going to think of is, okay, we have 1, 2, 3, 4. There's 3 possible places where we could put the plus symbols. Between the 1 and the 2, between the 2 and the 3, and between the 3 and the 4, and then there's variations of that. So we're going to need some sort of loop to go through every combination. And then if every combination doesn't work, that means that we are returning false. So that would be the scenario here. Okay, we went through every combination of pluses, so we return false. So let me show you like the basic how you go through this. So if we had the first example, which is 1, 2, 3, 4, and 37. So our original call to the function is going to be sums. So from this, I'm just going to like say, okay, so the string that we had is equal to 1, 2, 3, 4, and L. The long that we have, that I'm going to call L, is equal to 37. So basically, just looking at, we can originally start with this. Okay, if we look at these two, they're not equal. So we know we have to continue. So let's say we had an example where it was 56, and 56 is what we put into the function. Well, then you don't need to add any pluses, and it can just return right there. It can return 56. Okay, so back to the one we're on. So we knew that 1, 2, 3, 4, and 37 doesn't work. So if we're using recursion, we can call this function again, but make it smaller, right? Because recursion, we have to get like smaller and smaller, get closer and closer to a base. So our base is going to be when these two are equal to each other. That's when we're like done recurring. And when they're not equal to each other, we're going to have to do something to it. So if we look at this, we can look at the first number in our string and get rid of it. So if let's say for the next step, we did 2, 3, 4. And instead of making our target 37, what would our target have to be equal to? Because we're getting rid of the first one. So if we get rid of 1, then our target would have to be 36. So if you try to do another recursive call like this, we're making the problem smaller but still equivalent. Because we got rid of 1 from here, we're saying, okay, let's say 1 is the correct answer, is part of the correct answer. Well, we can take out that 1 and then make our new target 36, and this is an equivalent expression. And now we say the same thing. So over here, our prefix was equal to 1. And now if we do the same thing over here, our s is equal to 2, 3, 4. Our long is equal to 36, and they're still not equal to each other. So now let's look at the next prefix. what would our prefix be here? Two, yeah. Hold on one second. Okay. So if our prefix is 2, what could we call our next function? $34. Okay. Alright, so now over here, they're both equal to 34, right? So that's going to our like first scenario. So since they're equal to 34, we can add this to our stack. And now if we go backwards to where we were before, where you have this 234 and 36, well, we already know what's added to our stack is the 34. So in our stack is the 34. If we go back and add the previous prefix, so what's in our stack, our current was 34. If we add the previous prefix 2, that's going to equal to our target, 36. So now this statement is true. So now if we go back over here and we take our current and add the extra 1, then we have 34 plus 2 plus 1, and our original target is 37. So now that since this worked, we could add plus 2 to the stack. And since the plus 1 worked, we can add plus 1 to the stack. Does that make sense? I'll kind of write it out more in like a code way. So you're starting off with your original numbers and you're gonna make these prefixes. These prefixes are gonna be taken away from the target, so they're equivalent statements. So that's how we're saying here 1, 2, 3, 4, and 37 is the same thing as 2, 34, and 36. Now think about another scenario where we had 1, 2, 3, 4, and we want it to equal 46. Well, then the answer to this would be 12 plus, oh yeah, I don't think I really said this, but this is 34 plus 2 and plus 1 got added to the stack. So now if we print the stack, it would be 1 plus 2 plus 34. And then that's the answer. So you're adding to the stack from the order from the end already. So that way when you pop the stack, it's going to be in the correct order. Does everybody understand what a stack is? Or does anyone not understand what a stack is? No responses? Okay, write yes if you know what a stack is. Or you understand a stack. Okay. Okay, so basically, let's go over a stack. So a stack is what you think it is. It's just when things get stacked. So let's say we're gonna add, we have this list right here. 1, 5, 7, 10, 4. Okay. So when you add to the stack, it goes from bottom to top. So it's gonna be 1, and the next thing you add is gonna go on top. 5, 7, 10, 4. So I wrote it like this so it looks like they're stacked on top of each other. So you put it in, and then if you take it out, the first thing you're going to take is from the top. So you put when you put this into a stack, it's going to be 1, 5, 7, 10, 4. And then when you take out from the stack, you're going to take from the top. So you're going to take this, the 4 out, so it's going to print 4. And then if you take out again, it's going to get rid of the 10. If you take out again, then it gets rid of the 7. And then the 5, and then the 1. So it's going in last in, first out order. So it's like a stack of plates. If you're washing plates and you put them on top of each other, then the one you wash first is going to be at the bottom, and the one you wash last is going to be at the top. Then when you go to take a plate to get food, you're taking the most recent one that you washed. So that's all it is for a stack. Like technically, you could probably do this problem with like a list or something, array list. But basically the way that this is doing it is that it adds to the stack the 34 first, and then the 2, and then the 1. So key things to remember from this example is that we're going to keep taking away the prefix until we get the numbers being equivalent. And then once they're equivalent, we're going to add the previous prefixes to the stack. So yeah, back to this example here where we had the 12, 34, and 46. So we would do the same method, right? And have the same steps as before where we had sums. I'm just going to write the original function, 46. And so then our S is 1, 2, 3, 4, and L is 46. Guys, don't forget that this is a string, so like convert it to a long when you're parsing through it or using it for numbers, and then you probably have to put it back. So we have 1, 2, 3, 4, 46, and our prefix is 1. And then it's the same thing, right? Where these two are not equal, so we're going to have to do 2, 3, 4, and 46 minus 1. So now S is 2, 3, 4, and L is 45. And our prefix is what? Okay. And our prefix is 2. And then we're asking ourselves, okay, are these two the equivalent? No, they're not. So now what would our next function call be? Everyone can put it in I'm not going to continue until I get like 5 people put it. Yeah, exactly. So 34, and then we're doing our previous L minus the prefix. Okay, so what would, if the next time, now we have 34 and 43, they're still not equivalent. We have the prefix is 3, so it's going to have to be another recursive call. So what's our next recursive call going to be? Mm-hmm. 440. So S is 4, L is 40. And now our prefix is 4. So when we get to this part, so in the other example, once we got to the end, we saw that they were equal, and then we could easily just go back up. But here we got to the end, and they're not equal. So 4 and 40 are still not equal. If we get rid of the 4, then we won't have a string at all. So we can't continue with this. So that means that we know it cannot start with this. It cannot end with this 4 as the last number. So now that we know that this is wrong, what do we need to do? We need to make our prefixes be 2 digits. So if we continue this, we have to go back to the beginning. So this one is already done, or is already going on, and we're going to end up having this 2, 3, 4, and 45 case. Hold on 1 second. Okay, so why is it 45? Because our initial was 46, and we subtracted the 1 that we had from before. So this is the same thing where you have S is 2, 3, 4, L is 45. Are they equivalent? No. So what do you guys think the prefix is going to be now? Exactly. So we already went through all the prefixes being 1, and that didn't work. So we know that it has to increment. So it's going to be 23. And then we have to do the same thing where we take the new one is going to be 34. And what's going to go over here where the long was? So it's 45 minus 23, which is 22. So now we have S is 34 and L is 22. And of course, these are not equal still. Hold on. Hmm. 34. Okay. Sorry guys. Just got a little confused for a second. 34 and 22, yeah, so that's not equivalent. And this is going to continue until okay. Alright. So I messed this part up. So after it's 440 and you get prefix is 4, this is gonna be 422 because we got rid of the prefix, which was 23. Does that make sense? So basically, I'm sorry guys that I messed this part up right here. But here we had 234 and 45, right? And we saw, and the prefix is 23. So now we're gonna get rid of the prefix. And it would be 422. That part makes sense? Okay. So no one's saying it's making sense. So I'm just gonna go back, just go through it again. So we did this, we get rid of the prefix and we subtract the prefix. And we keep doing that until we get to 4. We can't subtract any more prefixes because then there would be nothing here. So now we had to go back to what we had before, which was 2, 3, 4, and 45, which is the same call from over here. And instead of
wasn't it 1, 2, 3, 4?
Yeah, that's the original.
So if we're doing it again, why aren't we counting the 1 again? Then wouldn't it be like 12 first then or something?
So yeah, technically yes, but it's just like how the format ends up being. Like it's gonna be the next one we're gonna do is the 12. Like it's because of the recursion that it gets like it's not gonna be 1 and it's gonna and it goes to this one first. 2, 3, 4. Like after 2, 3, 4, and 45, and then we get to 4 again. Now we're gonna go back to 1, 2, 3, 4. So yeah, if you have a way to do the 1, 2, 3, 4 again first, then that's fine. So now that we're back to the 1, 2, 3, 4, we're gonna go back to 46. And then we're gonna have our new S is 1, 2, 3, 4 again. And L is 46. And our new prefix is gonna be what? Okay, I can explain what I don't know who asked that before, but I think I understand like what you were asking better now. So all of these are recursive calls, right? And then once we got to here, we were done. We found out like we can't go any further. But we already know that this is like this is wrong. 34 and 43 is wrong. So it goes to this one. So when you're done with this, it doesn't automatically go back to the first one. It goes to the most recent recursive call. So this one is already not gonna work. So it has to go to this one. I think that's why. So now that we're back here with the 1, 2, 3, 4 and the 46, what's our new prefix gonna be? So we're done with doing just one number of the prefix. It has to be 2. So it's gonna be 12. And then the next call will be 34 and then 46 minus 12. So S is gonna be 34 and L is gonna be 34. So now that they're equivalent, we're gonna add the 34 to the stack. And then the last thing we have, it goes backwards because it's recursion, is gonna be adding the 12 to the stack. So this is why we did it in this like weird order. Okay, I know that was pretty confusing, but the important part to make sure you understand is you're taking away this, separating the prefix and subtracting that from the target every single time. So we had the 1, 46 minus 1, and we continue doing that until it doesn't work. So here it doesn't work anymore because we can't continue with 4 and 40. And we're going to do it again, except now with 2 prefixes. So we subtract 23 from 45, and then that didn't work. So now we went back to the original one, and it would be 12. And then then we continue, do the same thing again. 34 is equal to 34. We can add that to the stack, and because that was correct, we can return true and then add the 12 to the stack. So when it prints out, it's going to print the 12 first and then the 34. Okay, so that's pretty much it. Can you guys ask questions about it that you have?
So for the example with 46, you had to go to like the next phase of the for loop, so it starts taking 1 and 2.
Mm-hmm.
So for a situation where it'd have to do 1 plus 2 plus 34, would that mean we have to do 2 for loops, like an I and a J, like cutting up the main string?
No, you won't, because okay. What's gonna happen is like you see how we had the 1, 2, 3, 4, right? And it gets down to the like 4 and whatever. So if like hold on. So if it was 1 plus 2 plus 3 plus 4 is what you're trying to get to, right? Well, you're gonna keep going down and making your thing smaller until you'll eventually get to 4 equals 4, right?
Uh,
So so you can add the 4. It would add the 4 back, and then you would go backwards and then add the 3, add the 2, and add the 1. So that's why we're making the string smaller and smaller until we get to something that we know is correct. So once we get to something that we know is correct, it's gonna add that. So your for loop, you need to use substring, right? Or you don't
yeah.
need to, but this is one method, right? Use substring and start at the beginning of your string up until I. So that's what you're incrementing. In the original part, you're just doing the first one, 0 to 1. Or over here. You're just using the prefix 0 to 1, 0 to 1, 0 to 1 until it works in this case. But if it doesn't work, then you're going to have to do 0 to 2, 0 to 2, 0 to 2 until you get back down to only having one digit. Because when you have one digit, you can't take anything away anymore. Does that answer your question?
Yeah, that makes more sense.
Any other questions? Can somebody explain to me like an algorithm based on this now? Or like in general? Like what are we doing to figure out where the pluses are? And okay, so then if it gets through the whole entire thing and it never has s equal to L, then that's when you're returning false. Okay, who else has questions? Okay, so can someone tell me like what our base case is? Or what we're looking for? Okay, so the main thing that we're checking for is if the string is equal to the long. And that's why we keep making it smaller and smaller. So if these are not equal to each other, we want to make it easier and easier for it to be equal to each other. And once it is equal to each other, we know we can add that to our answer, to our stack. And then we need to keep doing that with the rest of the string that we missed before and do the same thing, see if it's equal to the new subtracted version. I know like this is kind of hard to understand, so please feel free to email me or send me a message on Discord so I can like go through it better with just you. Anyone want to share their concerns?
They're asking questions in the chat.
Oh, they are? Thank you. See, someone started speaking. Okay. Okay. How do you push the other elements from the previous calls onto the stack once s equals L? Okay. Let me like 1 second. Okay. Basically, you know how we keep adding the prefix every single time? So, I mean, once we get to the correct answer, you're starting to add the prefix back to the stack. So you need to have that in your statement. Like, if calling this function is true, if calling the recursive function is true, then we're going to add the prefix to the stack. So it already knows what the prefix is. It's just that once you know that the value is true, then it's going to add the prefix back. Let me stop sharing for a second so it's easier. Okay, so Brian, that part relates to what you were saying. You already know what the prefix is, right? And the prefix is what you're adding back to the stack. So once you check that it's true, make it to be like if that statement is true, if the recursive call is true, then you can add that prefix to the stack. If otherwise it won't do anything. But either way the prefix is being stored. Okay, sum s substring I. Okay, I think yeah. Yeah, so yeah, I think I see what you're saying. With a for loop from 1 to okay. You still don't get how to push all the elements on the stack. Okay. Yeah, okay, Kareem, if S equals L is added to the stack, yeah. Alright, Brian, can you unmute?
Yeah.
Okay, do you still not get it?
I'm just a bit confused. Like, I understand adding the string itself, but
Mm-hmm.
the thing I don't get is like the conditional in my head would be if the string is equal to the long, add it to the stack, and then
Mm-hmm.
that would, and then it folds back on itself. I just don't understand how to get it so that way you're constantly adding each prefix.
Uh-huh. Okay. So you need to do it as like I can't speak. Two separate like if state or two separate portions, right? So that one part that you're talking about is if they're equal to, right? If they're
Yeah.
equal to, you want to return true. So what that true is gonna allow you to do is be part of the second portion. So that second portion is gonna be okay, if the other part was true, the part that you just talked about, the n equal s, or the s equals l, right? If s equals l is true, then we're gonna add the prefix back.
So, all right. I think I get an idea. Hold on. All right, I'll try that and see.
Yeah, so
Yeah.
do it as like two separate things, and that way, adding the prefix is conditional on the two being equal. So once you
Yeah.
get to something that's equal, yeah, then you need to have an if statement that's going to be okay. If it returned true, or if somehow you know that it was equal, then you
So then
can
would
add the previous prefix.
the stack have to be created outside the method then? Because wouldn't it just constantly be overwritten if you're initializing it?
Yeah.
All right.